go ahead and work on the delta math because this is going to be pretty short. I'm just going to do a few examples on fancy factoring. Okay. So fancy factoring, or what I'm calling fancy factoring, is things we haven't talked about before. Yes. Oh, thank you. Hang on. All right, so it says you do not need to solve, guys. Everybody reading this? Okay. Just factor, it's all I care about. When there are 4 terms, like this first one, anybody remember what you have to do from Algebra 1 or Algebra 2? Yep, group. Okay, your best bet when there's 4 terms is to group things. So if I group these first 2 and these second 2, what can I take out of the first 2 terms? X squared, and that would leave in x plus 4. Everybody okay? I had some of you who were not factoring out a monomial correctly on the inverses, so you're scaring me. So please let me know if this isn't making sense. Now, the thing with grouping is that what's in the parenthesis needs to be the same for both. So what could I take out of these 2 that would put an x plus 4 in there? A negative or a -1. I'm going to write it as a -1, okay? Then what you're doing when you factor by grouping is you're taking out this common term and putting it in front and leaving the leftovers behind, what was left here and here. Are we done factoring for that problem? This binomial is the difference of squares, so it factors x plus 1, x minus 1. Everybody okay with difference of squares? So we had an x plus 4, an x plus 1, and an x minus 1. If we had to solve, we'd get -4, -1, and 1, but they didn't ask us to solve. Yes, some of them are just messy. All right. I'm not going to do a ton of examples of each kind, but let's talk about this number 2. When you have an x to the 4th and you have an x squared, what's going to happen is it's going to factor x squared and x squared. If you don't have an x to the 3rd or an x term, you can factor it x squared and x squared. Now, what are factors of 21 that might make a 10? Okay. And then remember, if you check your arches here, inside and outside, that will tell you if you factored it correctly. X squared times x squared is x to the 4th. This outside terms give me a 3x squared. The inside 2 terms would give me a 7x squared. And 7 times 3 at the back gives me 21. So does it add up to 10 in the middle? So we're good. It doesn't say to solve, so we're done. It would have only imaginary answers if we did solve. All right, number 3 is very similar. That's why I did that one. Has only an x to the 4th and an x squared. So we can break that x to the 4th into an x squared times an x squared. Factors of 18 that might give us 7. 9 and 2, okay? So we'd have a 9x squared on this arch and a 2x squared on this one. We need a -18, so one of them needs to be negative. And we need it to add up to -7, so I'm thinking the 9 needs to be negative. Okay. I didn't ask on the last one because they were both addition. The sum of numbers, they weren't perfect squares either. Just leave it at that. But this one is the difference of squares, guys. So that one factors further, would factor what? X squared minus 9 factors x plus 3 and x minus 3 in any order. And an x squared plus 2. 2 is not a perfect square to begin with, but a sum of numbers doesn't factor, even if it's a sum of perfect squares. All right, then they get real gnarly. Anybody think they have an idea what we might do here? It's really the same thing we were doing here. Yes, nice idea. X cubed and x cubed would make an x to the 6th. All right. Factors of 125 that might give us 124. 125 and 1. Okay, so now we have a 1x cubed on this arch and a 125x cubed on this one. Whoops, I lost the 5, sorry. We need the negative 125 and we need a negative 124, so I'm thinking that one needs to be negative and this one positive. Is that working? Okay. Do you remember how to factor a cubic? Okay, let me put the rules up here. A cubed plus b cubed equals a plus b times a squared minus ab plus b squared. And an a cubed minus b cubed is an a minus b times a squared plus ab plus b squared. That's the SOAP thing. All right, so we got a lot more work to do on this problem. Yes. Go ahead. Okay, if you're not sure, the cubed root of 125 is 5. You can type that into math. Under the math menu, there is a cubed root. Anytime you see an x cubed, you should check the other number probably to see if it's a perfect cube. All right, so for this particular problem, this is our a and this is our b. So what comes next is an a squared, which would be x squared, and a times b. Don't worry about the signs. So we get 5x, and then a b squared. 5 squared would be 25. Okay, and if the original one was minus, this first parenthesis is minus, but the other two are the opposite and always positive, or plus plus. I know they're painful. It's just a pattern. You have to memorize it. All right, what's this one? Cube root of x cubed is x. Cube root of plus 1 is plus 1. Now this is our new a and b. I don't know if I can scoot this over, and I'm almost out of room. Goodness, that would be a no. I can't scoot it over. All right, I'm just going to have to squeeze it in there. What is, can anybody give me that second parenthesis? Okay, so a squared was x squared, a times b was 1x, and 1 squared was 1. And if it was plus up here, it's plus in the first parenthesis, but then it's the opposite sign and always positive, so it's minus plus. All right, number 7. Last one I think I'm going to do with you is number 7. Anybody remember the very first thing you're always supposed to look for? Take out a common factor. What can I take out of all these? An x. What will be left after I take out one of the x's will be an x to the 4th plus a 5x squared minus 6. Then we just learned, don't lose that x out front, but we just learned today that when there's an x to the 4th and an x squared, we can factor that x to the 4th as x squared times x squared. Now we got to be a little bit careful because 2 and 3 and 6 and 1 both make 5, right? But we need the signs to be the same or different to get a negative 6. How do you get a negative 6, guys? Different signs, okay? So if the signs are different, what's going to make 5? Yeah, I think 6 and 1, because we need a positive 6 and a negative 1 so that we get a positive 5x squared. All right, are we done? Yeah, this guy is the difference of squares back here. So we get an x squared plus 6, and an x. How does it factor? X plus 1 and x minus 1. And everybody understands, because those are multiplication, we could put those terms in any order, right? And Delta Math would take them in any order. Okay? All right, I would like you eventually, before you leave today, to go back and try. You see how it says like number 9, like number 6? Yeah. So maybe we could you could work on finishing the rest of these. But for now, I'm going to go on and start 2.1. We're just going to do the first page of the notes because this is a review. Now it says you need a graphing calculator, but I'm not super sure you do need a graphing calculator. I'll just start mine up in case we need one. Oh, you know what? I'm not sure this is all review, but we're okay. We're just going to do a few of these and okay. A power function is anything in the form y or f of x equals x to some power. So if it was y equals x to the 0 power, it would be a constant, like y equals 1. If it was y equals x to the first power, it would be linear. If it was y equals x to the second power, it would be a parabola. If it was y equals x to the third power, it would be cubic. If it was y equals x to the fourth power, it's like a parabola, but it's a little flatter at the bottom. Well, not funky like that. If it was y equals x to the fifth, it's back like a cubic, but it's also flatter in the middle. Now, monomial functions mean there is one term only, okay? You can't have a plus something x or anything crazy like that. Or even a plus a constant on the back. Anybody need more time? All right. If the function has an even power and it is a monomial, okay, this is only true for monomial functions, one term. If it's an even power, it will be an even function and have y-axis symmetry. If it is an odd power, it will be an odd function, meaning origin symmetry. All the ones we just drew, okay, are either even or odd, depending on the power. The true reason that this is a lesson is that some of these things we're going to study in 2.1 are misleading on your calculator, okay? We're going to study rational exponents and radicals later in this lesson. but not today. We're just going to do the easy ones today. But the calculator can be misleading. Everybody got what they want off this slide or not yet? Okay. So if it isn't, we talked about this. Remember, we talked about this before. If you have the highest exponent power is an even power with a positive coefficient, both ends will go up. Does this sound familiar? If it's an even power, and this is like the highest degree, is an even power with a negative coefficient, both ends will go down. If it's an odd power with a positive coefficient, the right end is up. If you put a negative coefficient, then left end is up. Okay, we're supposed to write end behavior statements here. I really don't care which you start with. I will start with f of x because that's what I believe they do in calculus. This is up on both ends, right? So we can say as x goes to the left, and it is also up as x goes to the right. Anybody tell me the next one? F of x goes towards what? Okay, both of our y's, or f of x's, are going towards negative infinity. They're both going down. And then we say as x goes left or right. All right, then they get a little more complicated because we have to very carefully, if I'm going to do the left side first, okay, as x goes negative infinity, that means left. What is this doing on the left? As I go further and further left, it's going down, right? And then this one is going up as the x values go further and further to the right. And the last one, f of x is going up. This is up as x goes to the left. And f of x is going down as x gets bigger and bigger to the right. Remember all those, or do I need to go over again what means by left, right, up, down? Is this the next worksheet? All right, I'm going to be kind and stop here. How's that sound? All right, again, the assignment that you need to be working on, just because I wanted it part of the recording, is to make sure you have done the review after summative 5, which is in Delta Math, and then the fancy factoring assignment that's in Delta Math. And if you're up to date, you maybe will have almost no homework this weekend, right? For math?